In this video, we'll be looking at simultaneous equations and how to write them to represent a situation. Then we'll see how to solve them algebraically by using an elimination method, if they're both linear equations, and using a substitution method when one of them is a quadratic equation. Before going through this video, can I recommend that you look at the solving equations and also the quadratics equations video, as the processes used in that are also used in this video. Here we have a question in which Simon sells jam at a farmer's market. He's got two flavours, raspberry and apricot. Alice buys 3 jars of raspberry and 2 jars of apricot for £6.90. Ben buys 5 jars of raspberry and 3 of apricot for £11.10. The question asks, what is the price of each of the flavours? As we have two variables, we couldn't solve this with one equation, but we can create two. We can find the values of each of these where the graphs would intersect. We can also look to solve them algebraically, which means to find the value of both of the variables which are true for both equations. Firstly, we'll look at writing this out as an equation. For Alice, we've got 3 jars of raspberry, or 3R, plus 2 jars of apricot, or 2A. And we know that this equals £6.90. We can write that as this equation. We can do the same with Ben, who has 5 jars of raspberry, or 5R, and 3 jars of apricot, or 3A. And when added together, this makes £11.10. So we've now got two linear equations that both have the variables R and the variable A in them. We can use these to solve for both of these variables. Let's look at that process first before coming back to this question. Here we've got two linear equations, 3x plus 8y equals 97, and 2x plus 4y equals 58. For this, we're going to use the elimination method. That means we're going to add or subtract the equations to eliminate one of the variables and give us an equation with one variable that we can then solve. In order to do that, we need to decide which variable to eliminate and multiply each of the equations so that variable has the same coefficient as the other one. So here, we're going to get rid of the x variable, so we'll times the first equation by 2 to get 6x plus 16y, and we'll times the second equation by 3 to get 6x plus 12y. The first equation now equals 194, and the second equation equals 174. Now we're going to subtract the second equation from the first to eliminate the x variable, and then solve for the y variable. I could choose to do it the other way around and get the same results. So if we subtract the second equation from the first one, 6x take away 6x is nothing, or 0. 16y take away 12y would give you 4y, and 194 take away 174 would give you 20. If we divide both sides by 4, we'd end up with y equals 5. So now we know that y equals 5, we can use one of the original equations to substitute in the value for y and then solve for x. So if we take the first equation, we've got 3x plus 8y, which we now know to be 5, and that equals 97. If we multiply the 8 times 5, we get 3x plus 40 equals 97, and then we subtract 40 from both sides to get 3x equals 57, and then divide both sides by 3 to get x equals 19. Now I have a value for x and a value for y. We can double check our answers by using the second equation and substituting these values in. So if we substitute in the value for x being 19 into the second equation, so we've got 2 times 19 plus 4 times the y value of 5, and that should equal 58. 2 times 19 is going to give us 38, 2 times 5 would give us 20, and we can add them together to get 58. If you spotted that we could have eliminated the y value by just multiplying the second equation by 2, well done. That would have been a simpler method, but I wanted to show you how you can multiply both equations in order to get an answer. Now we'll see what happens if one of the variables is negative. Here, again, we've got two equations, both use x and y. However, the y value has a negative coefficient. So what I'm going to do is I'm going to add the equations together, as it saves time from having to deal with negative numbers, which I'd like to avoid. So I'm going to multiply the first equation by 3 and get 9x plus 6y, which will equal 48. Notice I've multiplied each of those terms and the answer by 3. The second equation I'm going to multiply by 2 and get 4x minus 6y, which would equal 4. I'm going to draw a line under these and I'm going to add these two equations together. And I'm going to add them because the values of the y coefficients are the same. One is positive and one is negative. And it'll eliminate the y variable and I'll be able to solve for x. So when we add these two equations together, we get 9x plus 4x would give us 13x. Positive 6y plus negative 6y would give us 0. 48 plus 4 would give us 52. We can now divide both sides by 13 and get x equals 4. Now that we've got x equals 4, we can take that value and substitute it into the original equation to find out what y is. So we can do 3 times x, which we know is 4, plus 2 times y, which equals 16. 3 times 4 would equal 12, so 12 plus 2y equals 16. I'm going to subtract 12 from both sides and get 2y equals 4. Divide both sides by 2 to get y equals 2. Now we've got a value for x and a value for y. We can substitute them both into the second equation just to double check our answers. So we'll do 2 times the x value of 4 minus 3 times the x value of 2. And that should give us the answer of 2. Well, 2 times 4 is 8. Take away 3 times 2, which is 6, gives us 4. So excellent. We can say our answers for the x and y are correct for this equation. So now we can return to the original problem of Simon's gem. We've got the two equations, 3r plus 2a equals £6.90 and 5r plus 3a equals £11.10. Let's get rid of the apricot jam in order to find out how much the raspberry jam is worth. So what we'll do is we'll times the first equation by 3 to get 9r plus 6a equals £20.70, and equation 2 will multiply by 2 to get 10r plus 6a equals £22.20. Now in this situation, I'm going to subtract the first equation from the second. So I'm going to take away 9r 6a equals £20.70 from the second equation. We end up 10r minus 9r leaves us with 1r. 6a take away 6a gives us 0. £22.20 take away £20.70 would leave us with £1.50. So r equals £1.50. Let's substitute that into the first equation to find out how much a jar of apricot jam is worth. So we can do 3r, which we know now is £1.50, plus 2a equals £6.90. We can multiply that out to be 4.5 plus 2a equals £6.90. Subtract the 4.5 from both sides to get 2a equals £2.40, and then divide both sides by 2 to get a equals £1.20. Now, knowing both of these answers, let's substitute it into the second equation just to double check our answer. So we have 5 times £1.50 plus 3 times £1.20 should give us £11.10. Well, 5 times £1.50 is £7.50, 3 times £1.20 is £3.60, and we add those together and indeed we do get £11.10. So we need to make sure that we write our answer. The apricot jam is worth £1.20 and the raspberry is worth £1.50. Here we're going to look at solving a simultaneous equation where one of them is a quadratic equation. In order to do this, we're going to need to use what's called a substitution method instead of the elimination method we used in the previous questions. To start off with, we'll find out what one variable is in terms of another. Sometimes you may need to rearrange the equations in order to do this, but in this example, we have y equals 2x plus 10. So we can write the equation like this. 2x plus 10 equals x squared minus 3x plus 14. So we can rearrange this because we need our quadratic equation to equal 0 by subtracting 2x from both sides and also subtracting 10 from both sides. That leaves us with the equation 0 equals x squared minus 5x plus 4. Now we can either use factorization to solve this or the quadratic formula. Remember, if they're asking you to round the answers, you'll probably need the quadratic formula. Here, we'll use factorization. So we know what the factors of 4 are. It's 1 and 4, 2 and 2. As the b coefficient of our quadratic is negative, we know that both of them are going to be negative because our c coefficient is positive. Negative times negative gives a positive. We need two that are going to add up to make 5, so 1 and 4 are going to be the candidates for it. So we can write it in brackets x minus 1, another brackets, x minus 4. Now that we've completed the factorisation, we've got two answers for x. X is going to be 1 or 4 in order to make one of those sets of brackets 0. As you saw in the graphing equation video, a linear equation can cross a quadratic twice. So we should have two answers for x in this case, 1 and 4. We can now substitute each of those back into one of the equations to calculate the y value. What we'll do is we'll use the linear equation because that's the simpler one to get the answer from. So we'll substitute in our first value for x, which is 1. We'll do 2 times 1 plus 10 will equal y. Well, 2 times 1 will give us 2, plus 10 would give us 12. So we know that 12 equals y when x equals 1. Now let's take our second value of x, which is going to be 4. So we'll substitute that in. 2 times 4 would give us 8, plus 10 would give us 18. So we can say that when x is 4, y is 18. We can write these like this. X equals 1, y equals 12, and x equals 4, y equals 18. You must make sure you write these in pairs, the x value with the correct y value. You can now see on this graph how these match up to the graphed solutions. Here we've got a quadratic equation and a linear equation. The quadratic equation would actually give us a circle if we plotted all the values of x and y for it. So what we need to do is we need to substitute in for our value of y in terms of x. So we're going to rewrite this as x squared plus, and then in a set of brackets, x plus 2, and another set of brackets, x plus 2, equals 4. Now the reason for these brackets is you have to remember the original y was squared. So we'd do x plus 2 squared would result like this. If we multiply these two sets of brackets out, we would end up with x squared plus 4x plus 4 equals 4. Now remember, we want a quadratic equation to have an answer of 0, or to equal 0, so that we can actually find out what our values of x are. So what we'll do is we'll combine the x squared to make 2x squared. The 4x won't be changed, but then we're going to subtract 4 from both sides, so we'd end up getting rid of the plus 4 on the end, and that would equal 0. So 2x squared plus 4x equals 0. We can then factorise this, and because there's no c coefficient, we only need one set of brackets. So the common factor between 2x squared and 4x will be 2x, and we'll put that outside of a set of brackets, and inside of the brackets we'd have x plus 2. Now, the solutions for x, we always have two solutions with a quadratic. So the first one would be whatever x is to multiply by 2 to get 0, and we know that if you want to multiply anything by a number to get 0, the answer is going to be 0. So we know that x will equal 0 there, and on the inside of the brackets we need to make that equal 0. So what would we add to positive 2? And we'd add negative 2 to get the 0. So we've got our solutions for x, which are 0 and negative 2. Let's substitute those into the linear equation to calculate our value for y. So in this case, we'd have y equals 0 plus 2, so we know that y equals 2. And in the other case, we'd have y equals negative 2 plus 2, which would equal 0. So now we've got our 2 points. We've got when x is 0, y is 2, and when x is negative 2, y is 0. Now this is actually the 2 points that the linear equation crosses through the circle, and you can see that on the graph just here. And you can see that it crosses through at x equals minus 2, y equals 0, and x equals 0, y equals 2. So in that video we looked at how you can write simultaneous equations to represent a situation in order to calculate what the two variables are for each of the equations. Next, we'll move over to the ratio topic and look at the foundations of how we go about calculating the values used. I'll see you then.